Every second, the internet moves an unimaginable amount of information. Searches, payments, artificial intelligence, cloud computing, video streaming, billions of digital conversations. Most people imagine electricity carrying that information. But electricity is only part of the story. The internet travels as light, not inside the air, not through space, but through strands of glass thinner than a human hair, invisible beneath our cities, hidden beneath the oceans, connecting almost every nation on Earth. These glass fibers have become one of the greatest engineering achievements in human history, quietly carrying the modern world at nearly the speed of light.
At first, the idea sounds impossible. Glass is fragile, transparent, ordinary. So how can it carry the world's information? The answer lies in physics. A laser sends pulses of light into an optical fiber. Instead of escaping, the light continuously reflects inside the glass, again and again and again, traveling enormous distances while remaining trapped within the fiber. Each pulse represents digital information, ones, zeros, the language of computers. Millions, then billions, then trillions of these pulses travel every second. What appears to be an ordinary strand of glass has become one of the fastest communication systems humanity has ever built.
The core of an optical fiber is astonishingly small, only a few micrometers wide, much thinner than a human hair. Yet inside that tiny strand, entire economies communicate, international businesses operate, cloud platforms synchronize, artificial intelligence exchanges information, financial markets respond. The size appears insignificant. Its impact is anything but. Sometimes, the technologies that reshape civilization are not the largest. They are the smallest, built with extraordinary precision, designed for extraordinary reliability, and capable of connecting the entire world through something almost invisible.
Before fiber optics, long-distance communication faced limits. Signals weakened. Capacity remained limited. Growing demand quickly overwhelmed existing infrastructure. Then fiber arrived. Suddenly, more information could travel farther, faster, with greater reliability. Entire industries began to transform. The internet expanded. Cloud computing became practical. Video streaming became global. Digital businesses became international. Artificial intelligence became possible at unprecedented scale. Fiber did more than improve communication. It changed what civilization could build. Because every technological revolution depends on infrastructure capable of supporting it.
For more than a century, electricity carried information. The telephone, television, early computer networks, everything depended on electrical signals. But electricity has limits. As information travels, signals become weaker, interference increases, distance becomes an obstacle. Fiber optics solved a completely different problem. Instead of moving electricity, it moves light. Light travels farther. Light carries more information. Light is almost immune to electromagnetic interference, and light can be amplified without rebuilding the entire network. This single innovation transformed global communications, not by making the old system slightly better,
but by replacing it with something fundamentally different. The modern internet is not powered by electrical communication. It is powered by optical communication, a technology capable of supporting the digital civilization we know today.
At first glance, one fiber appears to carry one stream of information. The reality is astonishing. A single optical fiber can carry many independent beams of light, each using a different wavelength, each carrying different information at exactly the same time. Imagine hundreds of highways occupying the same physical space, without collisions, without traffic, without slowing each other down. That is the power of modern optical networking. Video streaming, cloud computing, artificial intelligence, financial markets, government communications, scientific research, all moving together inside the same strand of glass, invisible to the human eye, yet supporting billions of digital experiences every single day.
Every modern city depends on movement. People move through roads. Electricity moves through power lines. Water moves through pipelines. Information moves through fiber. Without fiber, modern business slows. Cloud applications disappear. Digital payments stop. Hospitals lose access to critical systems. Financial markets become disconnected. The digital economy cannot function without continuous communication. That is why cities continue expanding their fiber infrastructure. Every new district, every technology park, every industrial zone, every data center requires connectivity. Because fiber is no longer simply a telecommunications network. It has become essential infrastructure, as important as electricity, water, transportation, and every other system supporting urban life.
Most of history celebrates visible achievements: bridges, skyscrapers, dams, airports. But one of humanity's greatest engineering accomplishments remains almost completely invisible. Millions of kilometers of fiber optic cable installed beneath streets, across deserts, through mountains, along railway corridors, across national borders, and beneath the deepest oceans, built over decades by thousands of engineers, construction crews, scientists, and technicians. Most people will never see this network, yet they depend on it every single day. Its success comes from remaining unnoticed, quietly carrying the information that keeps modern civilization connected.
History has always been shaped by materials. Stone built civilizations. Steel built industries. Oil powered the 20th century. Today, one of the world's most strategic materials is almost invisible: glass. Not the glass in windows, not the glass in buildings, but ultra-pure optical glass, engineered with microscopic precision, capable of guiding light across continents. Without it, cloud computing would not exist. Artificial intelligence would struggle to scale. Financial markets would slow. Global businesses would fragment. Modern communication would become almost impossible. The digital economy depends upon a material most people never think about, not because it is rare, but because it works so well that it disappears from everyday life.
every innovation built on the internet ultimately depends on a strand of glass carrying light through the darkness. Sometimes, the technologies with the greatest impact are the ones we never see.
The modern world feels wireless, invisible, instant, effortless. But beneath every digital experience, there is a hidden thread, a strand of glass, carrying light across cities, across countries, across oceans, connecting billions of people without ever asking to be noticed. Every search, every payment, every video call, every cloud application, every artificial intelligence response begins its journey inside that invisible network. Fiber optics did more than improve communication. It redefined what humanity could achieve together. It allowed knowledge to move faster, businesses to grow larger, scientists to collaborate globally, and entire civilizations to become digitally connected. The internet is often celebrated as one of humanity's greatest inventions. But behind the internet, there is another invention, quieter, hidden, yet equally extraordinary. A technology built from glass, powered by light, and trusted by the entire world. Because before information could reshape civilization, someone first had to teach light how to find its way home. NEXNET, the architecture of modern civilization.